Okay, so nomenclature is just another word for naming. This is definitely going to be important. If you can't name or identify chemicals, you are going to have a rough semester. All right, so if you need extra practice, make sure you do it. So nomenclature, we're going to start with covalent because those are the super easy ones. So these are things made of non-metals. These are the ones that get prefixes. So like mono, di, tri, so on and so forth. So to name a covalent compound, you use the prefix, and the prefix tells you what the subscript is. So it goes prefix, and then you just do the name of the element for the first element, name. And then the second element is going to be prefix. I'm going to do that the same way. Is going to be prefix, and then the name. And then you're going to change the ending to IDE. Okay, so all covalent molecules should end in IDE. Now, this is for things that are made of 2 elements. It gets more complicated with 3, but those are organic, so we're not going to worry about those right now. Okay, now ionic compounds are the ones that people usually struggle the most with because there's different naming schemes that you have to use for different groups. Okay, so if they are in group 1 or group 2, and when I say that, I mean group 1A or 2A, so alkali metals, alkaline earth metals, then you just name the metal, name metal, and then you name the non-metal. And then these should also be IDE. Okay, notice anything that is ionic gets no prefixes. Do not use a mono, a di, a tri, so on and so forth. No prefixes. If you include a prefix, it is incorrect and you will lose points. Okay, so name the metal, name the non-metal, IDE. That's it. Then if you have something that has a variable charge, now this is mainly the transition metals. I'm going to abbreviate as trans metals. Okay, there are a couple that have multiple different variable charges that are not transition metals, but these are mainly the transition metals. You have to have something that tells you what the charge is. This is where those Roman numerals come in. So you would name your metal, name metal. In parentheses, you're going to put a Roman numeral. I'm going to put a Roman number there. And then you're going to go on to name your non-metal with your IDE ending. Hang on, let me format those the same way. With your IDE ending. Okay, now the Roman numeral is not the subscript. It is the charge of the metal. Charge of metal. Okay, so that is its charge, and then you have to incorporate that into the formula if you're trying to actually figure out what the formula is. Okay, that number is not how many you have, it is the charge. Okay, and the last thing that you will run across are polyatomic ions. Polyatomic ions, you just don't change them to IDE. Don't change to IDE. So if something ends with a polyatomic ion, you just don't change it to IDE. Otherwise, use the polyatomic ion name. I won't have you memorize those. You probably will and should memorize a few that we use all the time, like nitrate, sulfate, but they are on a polyatomic ion sheet that I will provide you. Okay, so, and you get those on the tests as well, so keep that in mind. One that we did not do a good job of covering in 161 is naming acids. Okay, so this might be new for you, it might not, but this is a good review as well. So there's 2 types of acids. Okay, the first type of acid, there is no oxygen, and the second type of acid, if there is oxygen. So if they have oxygen. Now, how do you identify the 2, or how do you identify something as acid in general? It's going to start with an H, right? They're all going to start with an H. Starts with H or hydrogen. Okay, so if it has no oxygen versus if it has oxygen, they do have 2 different naming schemes. No oxygen, you actually start with the prefix hydro. And then you're going to name whatever the element or the polyatomic ion is. So hydro something, and then it either gets ick or us. Actually, no, these ones are all ick. I ignore that. Ick, hydro something, ick, acid. Okay, that's it. So if there's no oxygen in it, it's hydro, whatever the beginning prefix is, change the ending to ick. Okay, just like when we changed endings to IDE, it's going to be an ick, acid. Now, if it has oxygen, it does not get the hydro. You just name the element or the polyatomic ion, whatever it is, something. The ending is going to be ic or us, depending. I'll tell you what that depends on in a sec. And then acid. Okay, so no oxygen, hydro, something ic acid. If it has oxygen, it's either something ic acid or something us acid. The way to tell is by, you have to look at your polyatomic ions. It's always going to have a polyatomic ion in it. I'm just going to write poly. It's going to have a polyatomic. So you look at your sheet and you're like, okay, which polyatomic ion is it that is in here? The 8, if it ends in 8, it changes to ic. If your polyatomic ion ends in ite, it changes to us. Okay, so that's how you know and differentiate the two. 8 ic, ite is. The phrase that I use to remember these is, if you ate something icky, it's going to give you a sickness or an itis. So 8 ic, if you ate ick, you're going to get an itis. Okay, so 8 goes with ic, ite goes with us. There's some practice for this on the active chemistry. Okay. Now, if you're going the opposite way, if I give you the name and you have to tell me the formula, there's a couple things that you need to remember. First of all, if it is ionic, so if it has a metal and non-metal or a polyatomic ion in there, you have to check your charges. That's the whole point of that Roman numeral we were talking about. Okay. Don't just write it. Check your charges. This is so important. If you don't, you have the wrong formula. It throws off your stoichiometry and balancing and all of that stuff. Okay. Check your charges. Now, once you check your charges, the easiest way to figure out the formula is you crisscross those numbers into subscripts and you reduce them if they can be reduced. So check charges, crisscross, and reduce. Okay, so if they're both 2s, you can reduce them to 1s and so on and so forth. Okay, and then if I'm going the other way, so if I ask you to split them into ions, those subscripts should now become coefficients. All right, and you have to have charges. Okay, so if I'm ever talking about ions, something that needs an ion, you need to have your charges. Okay, so your cation is going to be positive. Cation is your positive one. All cats have pause. That's how I remember that. And anions are negative. Okay, so just kind of try to keep those in mind. I do have an example right here for most of these. So what I want you to do is maybe do the first one with me, and then you can pause and do the second one. All right, so we're going to write the following ionic compounds as their separate ions that would be found in an aqueous solution. So if I dissolve calcium chloride into water, and it is soluble, what ions would it break into? So I get a positive one and a negative one always. Okay, so if it's ionic anyway, so I get calcium and I get chlorine. Now, notice I did not bring the 2 to the right side yet. I haven't balanced or anything. I'm going to check their charges. Well, calcium is in column 2. It is always a +2 charge. Okay. Chlorine is in column 7. It is always a -1 charge. Okay. And I have, according to the subscript, 2 chlorines. That is how you should write it. Now, if it has a polyatomic ion, you should never change the subscript of a polyatomic ion, which is what Na2SO4 shows. Okay, so I want you to try Na2SO4. This is actually not supposed to be here. Sorry about that. And then I want you to try to do these naming examples here as well. Okay, so pause here and try your answers and then check your answers with me. Okay, so you should have gotten 2 sodiums and 1 sulfate ion here. Notice I did keep that 4 subscript because it's part of the polyatomic ion. That shouldn't change. And then you should check your answers here. I got carbon dioxide, P2O5, Fe2O3, copper 2 oxide, because if you check your charges, oxygen is -2, so copper had to have been +2. Cu2SO4 ammonium bromide, acetic acid. So with the acids, you figure out what the ion was. So acetic would have been from acetate. So the acetate ion is C2H3O2. It has a -1 charge, so I had 1 hydrogen to balance it out. HClO4, I would look for this polyatomic ion. It is called perchlorate. So I named it perchloric acid.